recursion and what is it. So recursion is basically when a problem can be broken into smaller parts. It forms a recursion tree, and the techniques of writing is like we need to find out what drives the code, what drives the recursion. uh, there has to be something that would drive the function to give it uh, a point where it could reach the base condition. So, and coming to base condition, or you can say exit condition. So these are basic things which we use for recursion, right? uh, there is a detailed video on top of this. If you want to see, you can check it out. I think that would be very much helpful. So just to give you a crux of how recursion works, now there is one new type of problem that I encountered, which is about partitions. Now partition is a very interesting concept. It is somewhat like what I had seen in that movie of uh, The Man Who Knew Infinity, I guess. There he talks about some formula about partitions. It's based on Ramanujan, excellent movie, but I did not understand much on top of that at that time. But now apparently we have some questions similar to those, uh, which we will be trying to solve here. Uh, by here I mean Leetcode questions. So I got a little bit of understanding on top of that, and maybe I thought that this is not that very well explained everywhere, or maybe I'm just a novice. So let's figure it out. So how does this partition, or what is partition? First of all, how does this partition comes different? Now there are questions where let's say that there is a rod. Okay, this is one of the, I think, classic problems for partition, that there is a rod. Okay, rod starts from, let's say, a rod or ruler. Let's say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Uh, so this is the problem that we'll be trying to solve, where I will be trying to explain how that problem needs to solve. Don't know why I drew now, but anyways, just keep this in mind. Okay, something like a ruler for now. Now let's say that we have an array. Okay, let's say there are we are talking about chocolates. Okay, due to some reason we like chocolates, but okay, 1, 2, 3, 5, 7. Let's make it arbitrary. Let's keep it as 9, 5, 7, 4, 3, and 2. Okay, something like that. Now the point of partition comes, now there are recursion problems. What is the difference between a normal recursion problem and a partition problem? So if we remember, uh, we had done something like this, right? Recursion. Okay, and inside recursion here comes dynamic programming for things which have common appearances, right? Something like that, if you remember. So similarly, inside recursion itself, we can find this partition related problems. So they are in a way derived from recursion, but they might have DP or dynamic programming that can be implemented on top of that or not, depending on the question itself. But without that, I think the partition related problem also comes here. Now, what is the basic difference between a recursion and partition? Okay. Now in recursion, you would have done questions like, let's say that how would you divide these three things or these five? How let's say that I want to take 3 chocolates. Okay, um, 3 chocolates, and I want to take up uh, minimum cost, where this is the chocolate cost. Okay, minimum cost, uh, or let's say this is let's make it a little simpler. Let's say chocolates, and this is the gram of chocolates. Okay, 9 gram, 2 gram, 3 gram, 5 gram. And I need to take 3 chocolates, and I want to take the maximum amount again. So this sounds similar. Maximum amount I can. It's actually one of the classical uh, greedy algo problem, which also comes under mm, this recursion. You can solve that by recursion, but it takes a lot of time in that case. But let's just assume that for now in this case. Okay, now we have solved this kind of questions, right? So what I mean to say is that in this case, what would the answer be? It's just a matter of selection. Um so selection or combination, basically, right? What we call uh, in mathematics is combination, and some other things that we need to know is partition. Partition is also somewhat near. Just I will draw the distinction. Just wait for it. So selection or combination, okay, and partition is different actually. So selection or combination is what, when you don't take into consideration the order in which you are selecting. Let's say, uh, so selection you may or you may not take. Order is not important, right? In partition, the major basic difference that I found it was order is important. Now let me explain how it works. So let's say same question, right? Three uh, chocolates, maximum amount I need to take, right? So I will pick, in that case, if I have to follow no order, okay, I don't have to follow any order of separation into that, then I will take 9, 7, 5, basic, right? Largest. This we were doing already with the help of recursion, right? Now in partition, when similar kind of question or this kind of questions are there, and they ask you that take one group, okay, take one group of 3 chocolates which are in sequence, okay, and that has to be the maximum, okay. In that case, will you take 9 to 3, 9 to 11 plus 3 14, or 5 plus 3 8 plus 7 15, or 7 plus 5 12 plus 4 16? In that case, this would be 5 7 4, right? This is the sequence of chocolate that I would take. Now basically partition, to make it very simple and clear, it's like, think that these are all physical entities, like 9 is standing here, 2 is standing here, 3 is standing here, 5 is standing here, 7 is standing here, 4 3 2. These are different peoples. And by partition, what do you mean contextually with the word partition? It means parting into two halves, right? So let's imagine like it's like putting a cardboard in between, okay, something like that. So when you partition this, now this is a different thing and this became different, right? Entity. So when we say partition, always think of it in this regard, that it's like putting in a cardboard or something that basically makes it into two different groups or more than one different group. So that's where the restriction comes. Now let me just summarize what I said so that maybe it would be a little bit more clearer. Uh, let's just change the color. Okay, so partition is basically when it is ordered, right? Ordered. And imagine it to be something like putting a cardboard, and the question that we will be solving may be cutting. I'll explain that in that question as well. But this is how the partition things work. Now the point that, okay, this might be something like that, that where we are thinking that it's like things are there, 2 5 11 3 9 7, some sequence. And we also understood that we need to think like we have put a partition, so basically separating these two, separating these three if I want. So the point is here that the partition can be put anywhere, right? And the question will be given in such a way that the partition or the way you are partitioning it, Okay, now you, in this kind of questions, you will have the choice or independence to part at any point, right? But that would give you a vague answer. So the point is that there will be some constant, like you need to maximize. And the way you are partitioning, the way you are going to partition, you are going to partition will determine, partition will determine whether you will get the correct answer or wrong, will determine whether it was the best way or not. It was the best way or not. Now, if you remember, some questions in recursion were also of the similar type, where we will find out the combination which is the best combination. So you go to recursively, basically dissect it into different trees, right? And make it different combinations, and then out of all those combinations, which combination you get the best answer, then that was the best way to go ahead. So basically you go out checking for all possibilities, similar to this as well. So here also it is like checking out all possibilities, right? Now let's say, mm, let's dive a bit deeper into this. Okay, so now partition is generally found to be one of the most difficult topics. So have a little bit more patience with me and try to keep up. I think I will eventually get there. I'm pretty sure we'll eventually get to the point where we understand it significantly better. So now let's say something like this. Okay. Uh, so there is a, let's say we are taking this sequence itself: 2, 5, 11, 3, 9, 7, right? And we have indexes of 0, 1, 2, 3, 4, 5. Now just imagine it like that, that at any particular index you can insert a cardboard or a partition so as to divide it into different halves, right? So I can insert, I can do it somewhat like that, that I will, let's say, uh, that for demonstration purpose, we'll say that we will start with index is equal to 0. I put a partition. Okay. Now index, if I put a partition on index 0, so let's say it would be something like this. Let's demonstrate. It will make the point clearer that I'm trying to make. So I'll just, okay. Uh, let's say it's like, so this is the array. Something is wrong. Why is it not drawing? Give me 1 second. Interesting. One second. I'll just refresh this. Okay. Seems we are back now. Okay, maybe we can draw now. Don't know somewhat. Some things happens. Okay. Anyways, sorry for the interruption. So let's see. Okay, fine. Let's say that let's just make it the way it is. 2, 5, 11, 3, 9, and 7, right? And the indexing is done in a way that okay, this is 0, this is 1, just the same thing. 3, 4, and 5. Let's reduce the thickness a little bit. Okay, now let's use a different color, okay, to draw our partition, right? Let's use it red color. Okay, imagine that I am putting a wall at 0. I put it here. Does it make any difference to the array? It doesn't, right? It's the starting point. So it's similar to telling you that, let's say that there is a rod which starts from here, 0, right? 0, and this can be n, right? If I cut it from here, if I cut it from here using this kind of a slit at 0, will it make any difference? Will you be able to cut anything? You won't, right? So there is no point to start from 0. Makes sense? Now let's say if we go ahead and we do that, okay, uh, same thing. Okay, let's say that I do it at I is equal to 1. Now 2, 5, 11, 3, 9, 7 are there, right? And the indexing is also 0, 1, 2, 3, 4, 5. Now if you say that I will put in wall or cut it at 1, right? So let's say I put the cut here, right, on the partition here. Now this would change, right? So in this case, what it does is that it differentiates into two parts. 2 stays here, 5, 11, 3, 9, 7 goes here. It basically, partition means slitting. Okay, let's call it like this, slit, cutting a slit in between two parts. Okay, now this makes a difference. Similarly, it will also make the same difference for I is equal to 2, I is equal to 3, I is equal to 4, I is equal to 5. I'm hoping you'll understand that. I will just draw the last one, I is equal to 5. Okay, let's see what happens in this case. Okay, same thing, 2, 5, 11, 3, 9, 7, right? And let's follow the index. I might leave it for the last. 0, 1, 2, 3, 4, 5. And I will start indexing at 5. Now tell me one thing. When you index it at 5 and try to do a partition, right? Try to do a partition. Will it make any difference? It won't, right? It's the same thing as the beginning or the end. Whether you do it as a beginning here, partition, or you do at the exact end point. You try to cut. Let's say it's a sausage, right? You want to eat it, and it has a length of 0 to 5, and I start cutting at the 0th point. Will I get anything? You won't get anything, right? Similarly, will you get anything if you start cutting it at 5? You won't get anything out of that as well. So the basic point that I was trying to make is that partition is just like, let's just write it here. Partition is like slitting or cutting, right? So and at this, and let's dive a little bit deeper. Now I hope that everyone has understood what I mean by partition, and how we are going to do that will come after this. It's actually okay, to understand how we are doing, what is being done or why is it being done, understanding that is more important. So that's why bear with me. Now we have got to the point that we have understood what actually partition is. It's basically slitting, right? It's basically cutting it into different halves, storing it, or differentiating it each other, right? Now let's dive deeper into this case, right? This case here, if you see, in I is equal to 1 partition. Okay, now these have become two different entities, right? 2, it has index of 0 now. Now here it has index of 0, 1, 2, 3, 4, right? And here again we can cut it at 0. So we can cut it, let's say x is equal to 0 to 4. Anywhere we can cut it. But since 0 doesn't make any sense cutting in the beginning, so we'll take it as 1. And this will take us n minus 1. Okay. As I explained, the cutting a rod exactly at where it starts or where it ends doesn't make any sense. Cutting a sausage exactly at the beginning or the end doesn't make any sense. So why do that futile operation? You can just make it x is equal to 1, 2, 3, right? We can cut it at 3 different parts. Now, so let's say that I choose to cut it at x is equal to 1. Okay, what would that do? That would make 5 at a different position and 11, 3, 9, 7 at another position. Similarly, x is equal to 2. It will also do the same thing, right? 5 and 11 at one position. Just to differentiate that we are doing it for different thing, I'm just putting this line 5, 11. Okay, and 3, 9, 7. Okay, and let's say x is equal to the last one, x is equal to 3. Okay, same thing, 5, 11, 3, 9 and 7, right? Makes sense, makes sense. Now each of these inside this are also now separate entities. So here also it will start from 0, 1, 2, 3, 0, 1, similarly, right? The point that I am trying to make is that the questions will be asked in a manner that where your choice of partition would determine whether the choice that you did was right or wrong. So the partition can occur at many places. Now in recursion, what used to happen was that we used to split a bigger problem into smaller problems. If you remember, bigger problem deal with smaller problems by breaking into smaller problems. Basically go on to making a tree. Does it not look similar to that? It looks, just there is one level of complication more than that, that at every point now you have multiple choice. Like you can slit it at any point. You can slit it at here this point, you can slit it at 9, 11, 3, 7, anywhere you want. Okay, and that would also determine whether the choice was right or wrong. So this is partitions, right? Because you can part it at any point, at any uh, instance, right? So if you, the point that I'm trying to make is that partition is also related to recursion, right? So the way recursion works, partition also works in the same way. But it can be that it can get, we have to try to make a chain at every point. At every point, we have to try to make a chain. Now let's come how to solve these kind of questions, right? So just to understand, so there are separate points where we can cut it, right? And for every one partition that we make two separate entities. Uh, Maybe it will be easier if I try to demonstrate it while writing. Let's see. So what I was trying to say is that let's say this is something, right? And this is a sausage, this is a rod or anything where 0, 1, 2, 3, 4, 5 is present, right? And I want to cut it. I can cut it at 1, I can cut it at 2, I can cut it at 3, I can cut it at 4, I can cut it at 5, right? And the choice that I make will determine whether I have made the right cuts or not. Okay, this sounds good, right? Cuts, right? So now let's say in this type of question, what you need to do that so let's say for everything there will be, and now let's say if I cut it at 2, okay, 0, 1, 2, and 3, 4, 5 goes this side. Now what will happen in that case is that for every dissection, right, dissection that you did, you again have to dissect it. You have the option to do it from 0 1 2 and 0 1 2 from the beginning index, right? So the recursion, it again has to traverse each of these spots, and for each spot you have to cut it, right? You have to cut it or you have to dissect it. Now in that case, I can also partition it here, here, anywhere I like, right? I have 2 points, 0 and 1, right? I can dissect it anywhere here. So if you understanding it right, so this partition can be done using recursion, right? Recursion plus iteration. You have to iterate over each point, right? Normal cases, what happens is that in recursion, the iteration is taken care by the driver code. So this will dissect it into two parts, and this will dissect into two parts. Okay, and we don't have to exactly iterate over each of this, right? Because we are telling it to break it into small fragments. But in this case, what happens is that it's something like this. It's present like this. Okay, now you can dissect it at any point, right? Let's say I make a choice to dissect it at the first one. Then 1 2 3 4 5 is present. I also have a choice to dissect it at second point, 3 4. I also have a choice to dissect it at third point, like this, right? So you have to iterate over each of these points, right? So that's why it becomes more interesting. Partition is basically recursion plus iteration. Now, not a big deal. Let's say we are writing a recursive function, right? We have given an array, right? And if we are going to do a recursion, okay, uh, the ideal way of doing it is with our favorite for each, not for each, for loop, right? And we need to have a starting point and a end point, so which here is meant by I and j. Okay, so I is start point and j is left point. Okay, let me just, so if you're understanding it right, so let's say this is a function now. Don't know why my handwriting goes so bad here. Maybe. Okay, this was just too thick. I'll just explain it again. Uh, so for iteration, we'll be using for loop. For recursion, normal recursive function, right? So let's say that my recursive function is this function, and I have array or whatever it is given. It might be a rod, it might be weight, it might be something, it might be something not, but it's mostly an array, or a sequence of numbers or whatever array. And we have a starting point, which is I, and j is our endpoint. Now the critical part that I realized by solving some questions is that how do you okay, before going to the critical part, let's get to the basic part. So as we know, in a recursive function, the first thing is to write the base condition. Base condition, why they call it, sounds more like an exit condition, better than, or exit condition, right? Base condition or exit condition. Okay, so this is basically starting, this is ending. What is the simplest base case condition? If I is greater than equal to j, then return, right? Simplest condition. If the starting point becomes smaller than the ending point, what is the point then? So this is the best condition in most of the cases. Now most critical part for this kind of questions is to understand uh, how to iterate, basically, right? I don't know why nobody mentioned about this, but the simplest way is the way I try to explain it. Think of it like sausages, right? One sausage, uh, or more. better way of thinking might be, okay, I'm just trying to improvise, my might be wrong. Think of it like a pearl set, closely wound pearl set, okay, pearls like this, okay, and I am asking you to do a dissection. So you cannot cut a pearl, right? You can only dissect this, cut it from here, make it one pearl here and the other 1 2 3 4 5 6 7 8 9 8 pearls this side. Think of it this way. So can you cut it in the beginning? Doesn't make any sense, right? Can you cut it at the end? Doesn't make any sense, right? What's the point of cutting it at the end? So if this is the 0th pearl, 1 pearl, 2 pearl, 3 pearl, 4th pearl, 5th pearl, 6th pearl, right? I can cut it when I at 1. When I say at 1, I mean between 0 and 1, the connecting rod, the connecting thread. Let's make it more clear here. So basically pearl, right, connected with threads, right? It's like this. I cannot cut it in the beginning. Cannot cut it in the end. Let's just number this for simplicity's sake. I cannot cut it at 0, right? I can cut it at 1. But when I say that I cut it at 1, pearl can't be cut, right? Only thread can be cut. So what, how we can cut here? When I say that cut at I is equal to 1, it means cut here between, implies that between 0 and 1. I, let's say I is equal to 4. That means here, right? So I can cut up to in that way I is equal to 6 also. Like that would mean cutting here, right? So you got my point, right? So we were trying to determine how to select the start and the end point, right? Okay, let's just, so the magic or the trick lies in selecting the start and end point correctly. Okay, that's the magic. This is what we need. This is all we need. Where to find the start point and where to find the ending point, right? And how will we do that? Imagine it like a pearl. And the way we did it already is that we could cut it from 1 to 6, right? Because when we say that cut at 6 implies dissection between dissection of the thread connecting 5 and 6, right? So we can cut it here. Now if we have understood this much, right, just bear with me, we are almost there. So what we had understood: recursive function, array, and a starting point and a ending point. We have found out somehow, right? With just simple observation, base condition: if I is greater than equal to j, return. Okay, now iteration, right? Here comes the iteration part, and all you need to do is for int, let's say k is equal to I, k, what is the endpoint? K is less than equal to j, k plus plus, and at every point, right, we have to dissect it into two different parts. So what would be that? uh, so one dissection would make it into two halves, right, at every point. So it would be one array. Now the array, how it would be that, let's say that it's a recursive function, so we'll be calling it again, right, function one for the starting one, array I and k, because at k point I have cut it, right? Let's say for k is equal to 3, the pulse are like this: 6, 0, 1, 2, 3, 4, 5. I say that I cut it 3. Now look at the interesting part. So I cut it here, right? Now when you cut it here, just tell me one thing: from 0 to 3 it will go in the beginning part, I to k, okay, and in the other part what will go? Function. And in the next part it will go from k plus 1 to j, right? Pardon my handwriting, but k plus 1 array, k plus 1 to j in this case. Okay, understand this one. What I'm trying to say here is that this is the critical part. So now let me come to the other part of this. We, for simplicity's sake, we said that we'll think of it as pearls, okay, with connecting threads between them, right? And anytime we cut it, it gets into two halves. But think now of it as a ruler, okay, ruler, or a sausage. Let's say sausage is present, right? You want to eat the sausage, and there are points 1, 2, this is 0, this is 3, this is 4, this is 5, this is 6. This is where it gets interesting. So here you cannot cut it in between 2 and 3. When you say, see, the interpretation is very important. Interpretation, let me say, the interpretation of a cut is very important. So some things I'm realizing while I'm teaching it. Interpretation of what a cut means according to question. Now if you see, if it's a sausage, I can cut it, right? I can cut it at the exact point 3, and then how it would divide 0, 1, 2, 3 on one side, same 3, 4, 5, 6. Think of it as a sausage that is marked, or simply a ruler. So it is calibrated, right? 0, 1, 2, 3. Now if you cut it exactly at 3, so in the one part 0, 1, 2, 3 is present. In the other part also 3, 4, 5, 6. Just that the 3 has now become the starting point of that, right? So if it is related to cutting down something of this sort, okay, generally the question is on this one only. Okay, the Pearl theory makes it easier to understand that the interpretation of a cut might be different. Okay, in this case we follow the same norms. Okay, same ideology, or same idea, basically not ideology, it's a wrong term. Okay, now let's say the function we are writing, right? An array I, of course you cannot cut it at 0 or 6. So the starting point I and j, where I can go from 1 to 5. You cannot cut it at 6, right? How will you cut at exactly at the end point? No. So here the I to 1 to 5 changes, right? And interestingly, base condition will also remain the same. If I is greater than j, return greater than or greater than equal to, depends on the question sometime. So let's keep an open mind about it. But now the interesting part, iteration part. For int k is equal to I, start with I, k is less than, do we go to the end point? 0, 1, 2, 3, 4, 5. Let's say I is equal to 1 to 6 or 1 to 5, that means 1 is less than equal to I is less than 6, right? The index. So I can write it as k less than j, in this case k plus plus. And now comes the most significant part of the recursive code. So we'll split it into function array. Let's say we are doing it I is equal to 3. I'll just array, then I, then k, right? And the other part also, it would be function array since 3. If you see, it is present in both the parts in this question, so it would be array k and j. This is how it works. Okay, so if you can just visualize or understand or interpret the cut. Okay, now let me summarize it all up in one last section, what you need to understand by partition, and then maybe we'll solve another question after that, that how to basically understand that. So now let me just summarize this. Partition. So partition, okay, partition is simply what we call this summary, right? Just make it a heading. Summary. Partition is simply recursion plus iteration plus cut interpretation. There are two types of partition. Perl type, as per now. If I come across some other variety, I would love to include it. So I'll just take into consideration my limited knowledge. Perl type or rod type, let's say. Perl type, what does this mean? Basically pearls. like this, right? Rod type, what does basically it mean? It's a rod, calibrated rod. Here it is 0 1 2 3. So cut interpretation, coming to the most important part. Recursion plus iteration plus cut iteration plus when we say iteration, uh, start and end is an absolute necessity in understanding it. Now when we see this 0 1 2 3, so what does cut here mean? Let's say cut at I is equal to 2. This would mean 0 1 would be present. You can't cut pulse, right? You'll cut the thread between them. 2 3, right? Cut the thread, not pulse, right? Now let's understand what here cut means, the interpretation. Cut at, something is terribly wrong with my handwriting. We'll write it in maybe different ink. Cut at I is equal to 2. What does this mean? That it will cut it in like this, 0 1 2. And the same 2 will also be present here, right? 2 3 4 5 6, and depending on these two cuts, depending on the cut, you have to solve. You have to select start and the dissected parts. That's the crux of the whole thing. So that's where it lies. What happens after that is that maybe you will have a cost, or maximizing the cost, minimizing the cost. That all comes according to the question. Okay, but this is the basic crux. Okay. Uh, let me just also summarize the function for you. So the function will have the recursive function, right? So the function will have array, start, end. If I is greater than j, return base condition. Okay, and then according to question, whatever the variables would be there, for int I is equal to, sorry, k is equal to I, k is less than j k plus plus. And inside this, what will you be having? It will be having the function recursive part, array I to k plus function array I k or k plus 1 to j, and whatever the operation you might need to do. So this is the whole summary of partition. Hope you have got a understanding about this, and this will be helpful. This will be more clear once we solve the problem, the classic rod cutting problem. Till then, just try to understand, and please leave comments if there are any doubts. I will try to clarify. Thank you.